Mutability in programming. What the heck is that? Well, first things first, welcome to this video on mutable versus immutable objects. Have you ever wondered why some objects can be modified while others cannot? Understanding the difference between mutable and immutable objects is a fundamental concept in programming. It can have significant impact on the performance and behavior of your code. In this video, we will explore the key differences between mutable and immutable objects and examine some practical examples to help you master this concept. So let's dive in and explore the world of mutable and immutable objects. A mutable object is an object whose state can be modified after it is defined. In other words, the ability of an object to change their values. An immutable object state cannot be altered. Once created, the value of an immutable object is permanent. Okay, well, that's it for definitions. But what is actually the difference? How are they represented in programming? Don't worry, I'll be walking you through these concepts in more detail throughout the rest of the video. For starters, let's go over data structures in Python. And also, if you aren't a Python programmer or you're learning a different language, don't fret. These concepts are consistent across all programming languages, so just keep that in mind when you see syntax or naming conventions that might be slightly different as we progress through the rest of the video. Okay, so data structures in Python. For mutable objects, we have lists, sets, and dictionaries. For immutable, we have numbers, booleans, strings, and tuples. While the characteristics are different across these types, they all share three attributes. Identity, which is the address that the object refers to in the computer's memory. Type, which we already covered, is the kind of object that is created, string, list, integer, etc. And lastly, value, which is the value stored by the object. For example, a list with 3 elements, 1, 2, 3, holds the number values of 1, 2, and 3. I also want to point out that type and ID cannot change, even in mutable objects. Mutable objects can only alter their values. That out of the way, let's dive deep into some actual code. I'll walk you through the basics and provide some practical examples of mutable versus immutable and implications that it has for memory management. Towards the end of the video, I'll share with you some gotchas that you may run into if you don't use immutable types effectively. So now let's begin by going through our types again. I'll initialize each type and also print them out with their type and values with an F string. So to start, we have a string. My string is equal to, this is my string. And then let's go ahead and print this guy out. We'll make it an F string and we can do value. And then we'll do my string. And then we'll also do type. And we can do type, which is a standard method in Python. And just to make sure that that works, let's go ahead and run this code. Boom, the value and the type. So let's go ahead and do that for the rest. So we have number or integer. So let's do my number is equal to 1. And then because I'm lazy, let's just go ahead and copy this over. My number. We also have tuples. So we can do my tuple is equal to. And then we do this is my tuple. Boom, boom, my tuple. And the last immutable object is a boolean. We'll do true. And then we'll also do this for the false value. Might as well. Boom. Okay, so let's go ahead and run this. We can see we have, this is my string, the string, integer, class of tuple, and 2 booleans of true and false. Amazing. Now let's go ahead and clean this up and we'll get going with the mutable types. For mutable types, we can go with a list and we'll just initialize it with values of 1, 2, and 3. Let's print it like we did previously with the immutable types. And we can do value, my list, type, my list, close that up, and then we can do my set, which unlike list is going to have curly braces, and we'll just do the same here. 1, 2, 3. Might as well do this and then copy this down, and then we can do my dictionary, and you can initialize that with curly braces as well, but we can provide a key and a value. All right, copy this over, boom, boom, give it a rip, and we printed out a list, set, and dictionary, which has a key and a value pair. Amazing. So that's it for our types. Now let's go over to a couple of examples, looking into more of how memory management works with a string. So here we have it already started with the string initialized and printed. So let's now go and modify the immutable string variable by assigning it to a new value. Now let's go ahead and run and check the output. You may be asking yourself, well, if strings are immutable, why does this print change outputs? Well, the underlying data stored in memory doesn't change, but rather a new object to store the other value is created. To show this more clearly, let me introduce you to the ID method in Python. This will print out the identity of the object, which is the memory address of the underlying value. Now that we have new print statements with the ID method, let's go ahead and run the code. If the addresses were the same, we would infer that the underlying data was actually modified in place, but because they are different, we know that we did not modify the first string. This is how we know strings are immutable. To really drive the point home, here's an example of how we will get an error when actually attempting to modify a character of a string. We have, whoa, this is a new value. Is that possible? As the value of our string. And let's try to modify the first character by capitalizing W. We can do this by accessing the first element in the string and then assigning it a new value. Now what happens when we run the code? Boom. Yep, exactly what I thought, an error. Okay, here's one last example for strings. We assign it as old value, we reassign it with new value, and then we go back and revert it to the original value of old value. Wow, lots of values. But anyways, just wanted to run this so we can print out the value with the address. Go ahead and run that, and you can see the first and the third print statement share the exact same memory address. So we're not actually reinstantiating, in a new location, this old value. We've already initialized it and it exists in memory. So instead of recreating a new address in memory, we're just reassigning it to the original address. Now let's walk through an example with list, which if you recall is a mutable type. So if we have my list is equal to 1, 2, 3, 4, 5. Unlike the string example, we can actually modify the value of one of the elements in this list, or any of the elements in this list. So if we wanted to, and I can just go ahead and print this with our f string again, and I can do my list with address, and we'll do ID my list. Let's run that. You can see the address is there. Now, unlike the string, we can modify elements of it in line. So if I do my list and we want to access the first element in the list, and let's just modify it to 99. And then we can go ahead and print out the list. And now if we run this, you can see that the address, even though it's been modified, the data address or the memory address of the list stays consistent. So to close this baby out, I want to go through one last example that's going to give you some real insight into, why immutable and mutable distinctions are fairly important, especially when it comes to memory management. So let's say, for example, you had a situation where you wanted to just simply concat a bunch of data together. So let's say we had a list of games string, and we wanted to concat all of the names in this list together just like as an example of data, right? So what we could do is we could loop through the games in our list. And then what we'll do is we'll just do list of games string. Then we can cat each game together, right? And then let's print this out and we can do list of games string, go ahead and run that, and boom, loops through and continuously concats it together. Now, the thing about this is that this string that we're instantiating is an immutable object. So every time we can cat something together, it's going to be taking up more room in our memory, right? And to visualize that, we can do what we've been doing is print out the f string with the actual value of the string. So we'll do list of games string with address of, and I need to fix this up, but here, let's just go ahead and finish this out. And then boom, and then boom, okay? And then let's run this one last time. And you can see that the memory address is changing. So here it's different, 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 right? So we can bloat our memory pretty significantly when we are using immutable objects in unexpected ways. So just wanted to leave you with that little tip. I've really enjoyed going through this concept with you all, and I hope that you really enjoyed. If you want any more tips of programming in the future, leave a comment below in terms of all of the different things you'd like me to cover. Again, I hope you enjoyed. Leave a like, it really helps out with the channel, and I'll see y'all in the next one. Peace.